The Milky Way is more than just a faint band of light stretching across the night sky. It is a world of secrets, a cosmic enigma that holds stories we can barely begin to comprehend. What if the galaxy you call home is hiding extraordinary phenomena, from ancient stars older than imagination to invisible forces shaping its very existence? Scientists have only scratched the surface of the mysteries lurking within its swirling arms and luminous core. By the time we reach the end of this journey, you'll uncover 25 secrets about the Milky Way that will challenge everything you thought you knew about our place in the universe. So fasten your seatbelt as we embark on a voyage into the unknown to reveal the astonishing truths of our galactic home. Now turning to our first secret, we dive into the heart of the Milky Way, where a monstrous entity lurks, Sagittarius A, the supermassive black hole anchoring our galaxy. This cosmic giant, with a mass equivalent to over 4 million suns, exerts an incredible gravitational pull, reigning supreme at the galactic center. Stars in its vicinity are drawn into a chaotic dance, whipping around it at mind-boggling speeds, some moving as fast as 15 million miles per hour. Scientists believe Sagittarius A* plays a critical role in not only holding the Milky Way together, but also shaping its very structure. Its immense gravity influences the orbits of countless stars and interstellar gas clouds, which in turn dictates the galaxy's spiral arms and dynamic evolutionary patterns. Despite its enormous power, Sagittarius A* remains cloaked in mystery. Unlike what movies might suggest, it is not actively devouring stars or planets. It is currently a quiet black hole, consuming only small amounts of matter that stray too close. This relative calm gives researchers a unique opportunity to study how such objects influence their environment without the chaos of active feeding. Recent advancements in technology, such as the Event Horizon Telescope, have even allowed us to capture images of the glowing ring of gas around Sagittarius A*, marking an unprecedented step forward in understanding these enigmatic phenomena. It is awe-inspiring to think that amidst the vast cosmic landscape, this silent, invisible force at the Milky Way's core continues to shape our galaxy's destiny. And yet, as we zoom out to explore more, the mysteries begin to multiply. Moving forward, we encounter another astonishing mystery of the Milky Way, the enigmatic gamma-ray structures known as the Fermi Bubbles. These colossal formations stretch tens of thousands of light-years above and below the galaxy's disk, glowing with high-energy radiation. Discovered by the Fermi Gamma-Ray Space Telescope, these bubbles are unlike anything else observed in our galaxy. Their sheer size and energy output suggest some incredibly violent event in the Milky Way's past. Scientists remain divided on their origins. One leading theory points to Sagittarius A*, the supermassive black hole at the galactic center, speculating that an outburst of energy from its accretion of matter millions of years ago could have created these massive structures. Another possibility involves periods of intense star formation near the galactic core, where exploding supernova and stellar winds might have collectively produced the energy needed to inflate these enormous bubbles. What makes the Fermi bubbles even more intriguing is their sharp edges, which indicate a well-defined and recent event rather than a gradual process. Researchers are also studying their unique composition, as they appear to be filled with accelerated particles and magnetic fields, revealing clues about the extreme processes shaping our galaxy. Despite years of study, these gamma-ray bubbles remain a cosmic puzzle, challenging our understanding of galactic evolution and energetic phenomena. As we ponder their mysterious origin, we find ourselves drawn further into the Milky Way's endless depths of hidden wonders. Now turning to another profound mystery, we uncover the invisible substance known as dark matter, which silently dominates the Milky Way's mass. Unlike the stars and planets we see, dark matter does not emit, absorb, or reflect light, making it impossible to detect directly. So how do we even know it exists? Scientists infer its presence through its gravitational effects. For instance, when observing the rotation of our galaxy, they notice that stars far from the center move much faster than they should based on the visible matter alone. This discrepancy points to the existence of an unseen mass holding the galaxy together, dark matter. Estimates suggest that dark matter accounts for about 85% of the Milky Way's total mass, enveloping the galaxy in an immense invisible halo. Yet, what exactly is dark matter made of? That remains one of the greatest unanswered questions in modern astrophysics. Some theories propose exotic particles that interact only through gravity and weak forces, while others suggest entirely new dimensions or physics beyond our current understanding. Despite decades of research and advanced detection experiments, dark matter continues to elude direct observation, challenging scientists to rethink the very fabric of our universe. Its discovery would not only solve a cosmic puzzle, but also unlock a deeper understanding of the forces shaping galaxies like the Milky Way. As we journey further into this enigmatic realm, the mysteries only deepen, revealing how much more there is to uncover about our galactic home. Moving forward, let us explore the Milky Way's enigmatic halo, an immense and largely invisible region surrounding our galaxy. This halo, composed of a mix of stars, gas, and dark matter, stretches far beyond the dense, spiral arms we typically associate with the Milky Way. While once thought to be relatively compact, recent discoveries suggest that this halo extends much farther than previously imagined. Using sophisticated instruments, astronomers have detected faint stars and gas streams at extraordinary distances, hinting at a structure that could span hundreds of thousands of light-years across. This expanded halo challenges prior calculations of the Milky Way's size and mass, indicating that our galaxy might be significantly larger and heavier than earlier estimates. The halo's dark matter component, in particular, appears to play a crucial role in stabilizing the galaxy's structure and influencing its gravitational interactions with neighboring galaxies. Studies also show that this mysterious halo holds clues to the Milky Way's turbulent past, including evidence of smaller galaxies being torn apart and absorbed into the halo over billions of years. Each discovery reshapes our understanding of this vast, diffuse region, revealing its importance not only in the Milky Way's evolution but also in the broader dynamics of the universe. As our instruments become more advanced, the exploration of the halo opens the door to unlocking even deeper secrets about the nature of galaxies and the unseen forces that govern them. Now turning to the intriguing structure of our galaxy, let us uncover the barred spiral mystery of the Milky Way. Unlike a simple spiral galaxy, the Milky Way features a distinct bar-shaped structure made up of densely packed stars and gas at its core. This bar is not just a decorative feature, it plays an essential role in the galaxy's dynamics. Acting almost like a cosmic conveyor belt, the bar channels gas from the outer regions of the galaxy toward the center, fueling the formation of new stars and feeding the supermassive black hole, Sagittarius A at the core. The presence of this bar is a key factor in the Milky Way's classification as a barred spiral galaxy, a structure shared by many galaxies in the universe, though the reasons for its formation are still the subject of intense study. Scientists have theorized that bars may emerge in galaxies as they age, resulting from gravitational interactions or instabilities within the spiral arms. Understanding this bar is vital because it serves as a window into the Milky Way's past, offering clues about how the galaxy has evolved over billions of years. Research also shows that the bar influences the orbits of stars and the distribution of gas, shaping the overall structure of the galaxy in profound ways. By studying this fascinating feature, astronomers hope to answer fundamental questions about the life cycles of galaxies, adding yet another layer to the mysteries of our cosmic home. Moving forward, let us dive into the heart of the Milky Way, the galactic core, where the density of stars reaches unimaginable levels. Unlike the calm and spacious region of our solar neighborhood, the galactic core is a realm of chaos and intensity. Stars here are packed so closely together that the distance between them is measured in light weeks rather than the light years common in our corner of the galaxy. This extreme crowding creates a gravitational dance that is both mesmerizing and perilous. Interactions between these stars are frequent, with their gravitational forces pulling at one another, sometimes altering orbits and even triggering stellar collisions. The energy from these close encounters can send shockwaves rippling through the surrounding space, often disrupting any planetary systems that might have formed around these stars. For perspective, imagine living on a planet in this turbulent region. Night skies would be ablaze with the light of countless stars, far brighter than anything visible from Earth. However, this stunning view comes at a cost, as the gravitational chaos would make it almost impossible for planets to maintain stable orbits, let alone nurture life. Researchers study the galactic core to better understand these interactions and the unique conditions that exist there. This star-packed environment also offers clues about the early stages of our galaxy's history, as many of the stars in this region are remnants from its turbulent beginnings. By analyzing this dense core, astronomers hope to unravel not only the mysteries of the Milky Way's formation, but also the factors that make regions like our solar neighborhood a relatively calm haven in this cosmic storm. Now turning to the phenomenon of rogue stars, these are fascinating celestial objects that have been ejected from the galactic core at truly staggering speeds. Known as runaway stars, their journeys across the galaxy are nothing short of extraordinary. But what could propel a star to break free from its home and hurtle through space at such remarkable velocities? The answer often lies in dramatic gravitational interactions. Imagine a star venturing too close to the supermassive black hole at the Milky Way's core, Sagittarius A. The immense gravitational forces at play can slingshot the star out of the region, sending it speeding away at hundreds of thousands of miles per hour. In other cases, a supernova explosion, a violent stellar death, can act as a cosmic cannon, blasting nearby stars into motion with incredible force. To put this into perspective, some rogue stars move so quickly that they can eventually escape the gravitational pull of the entire Milky Way, becoming intergalactic wanderers. These high-speed journeys make rogue stars invaluable to researchers, as studying their trajectories helps scientists map out the unseen gravitational forces within the galaxy. Interestingly, some of these runaway stars carry the remnants of their origin stories, such as heavy elements forged during a supernova or unusual orbital paths that hint at past interactions with black holes. These characteristics not only reveal details about their chaotic past, but also offer clues about the dynamic processes shaping the Milky Way. The existence of such rogue stars underscores the sheer range of forces at play in our galaxy, from the immeasurable might of black holes to the explosive power of dying stars. And while their velocities and trajectories may seem extraordinary, they remind us of the complex gravitational web that binds our galaxy together. Their journeys through the cosmos are a testament to the unpredictable and often violent nature of the Milky Way's inner workings. Moving forward, let's uncover an astonishing feature of our galaxy, its warped disk. Picture the Milky Way as a near-flat, spinning disk of stars, gas, and dust, but with a surprising twist, it is not completely flat. Instead, the edges of the disk bend and ripple, creating a warped appearance that has baffled scientists for decades. So, what could cause such an unusual phenomenon? The answer lies in the intricate gravitational dance between the Milky Way and its smaller neighbors, the satellite galaxies. These diminutive galaxies, such as the Large and Small Magellanic Clouds, exert a persistent gravitational tug on the Milky Way, warping its structure over time. Additionally, interactions with streams of intergalactic gas, which flow through the cosmos like invisible rivers, further contribute to this distortion. But the warp is not static, it moves and changes over time like waves rippling through water, giving the Milky Way a dynamic and ever-shifting structure. These motions are not merely cosmetic, they hold valuable information about the galaxy's history. By studying the warp's patterns and behavior, researchers can piece together the story of past encounters with other galaxies and understand the unseen distribution of dark matter that envelops the Milky Way. Dark matter, an invisible but dominant force in the universe, plays a major role in shaping these dynamics, like a hidden framework that holds the galaxy together. This warped structure challenges the idealized view of galaxies as perfect disks and reminds us of the Milky Way's active, evolving nature. As we delve deeper into this cosmic quirk, it becomes clear that the Milky Way is a galaxy in constant motion, influenced by forces both near and far, visible and invisible. This complexity only adds to its allure, showcasing the interplay of gravity, matter, and time on a grand scale. With its warps and wobbles, the Milky Way's disk invites us to wonder what other secrets might be hidden in its sprawling, dynamic expanse. Now turning to another fascinating aspect of the Milky Way, let us explore the ghostly stellar streams that weave through its vast expanse. These streams are like cosmic breadcrumbs, the remnants of smaller galaxies that were gradually torn apart and consumed by the Milky Way's overwhelming gravitational pull. Among these, the most well-studied is the Sagittarius stream, a sprawling river of stars that arcs through the galaxy like a celestial scar, tracing the path of the Sagittarius dwarf galaxy as it was dismantled. But this is not just a story of destruction, it is a story of growth and evolution. By studying the Sagittarius stream and other similar structures, scientists can uncover how our galaxy has grown over billions of years by merging with and absorbing many smaller galaxies. These interactions are not random, they follow the intricate choreography of gravity, revealing how the Milky Way's structure has been shaped and reshaped over time. Moreover, the stars in these streams carry chemical fingerprints, a kind of cosmic DNA that tells us about the conditions in their original galaxies. These clues help researchers reconstruct the history of galactic collisions and mergers, offering profound insights into the life cycle of galaxies in the universe. The study of stellar streams also sheds light on the distribution of dark matter, as the paths these stars follow are guided by the unseen gravitational influence of this mysterious substance. Like invisible scaffolding, dark matter shapes the orbits of these stellar remnants and provides a window into its elusive properties. The Sagittarius stream, with its haunting beauty, is more than just an astronomical curiosity. It holds the key to unlocking many of the secrets behind the Milky Way's past and its intricate gravitational web. As scientists continue to map these streams, they piece together an epic tale of cosmic cannibalism and creation, painting a picture of a galaxy that has thrived and flourished by absorbing the remnants of its smaller neighbors. This dynamic process not only highlights the Milky Way's growth, but also reminds us of the interconnected nature of the universe. With every discovery, the ghostly stellar streams draw us closer to understanding the forces that shape our galaxy and ultimately our place within it. Moving forward, let us delve into one of the Milky Way's most awe-inspiring secrets, the oldest stars that inhabit this ancient galaxy. These stellar relics, some over 13 billion years old, are like time capsules from the dawn of the universe. They were born shortly after the Big Bang, when the first elements began to form and coalesce into stars. These ancient stars are primarily composed of hydrogen and helium, the simplest and lightest elements, because heavier elements like carbon, oxygen, and iron did not yet exist. By studying their chemical compositions and other properties, scientists can glimpse the conditions that prevailed in the early universe before the formation of large galaxies like the Milky Way. These stars are often found in the galaxy's halo, a spherical region of faint light that surrounds the central disk. Their locations suggest that they are remnants of the Milky Way's earliest stages of growth, a time when smaller proto-galaxies merged to form the galactic structure we see today. By analyzing their light, astronomers can determine their age and trace the timeline of star formation in the universe. These ancient stars also play a crucial role in refining our understanding of cosmic history by offering clues to the rate at which the universe expanded and evolved during its infancy. They are a living testament to the processes that shaped not only our galaxy, but also countless others scattered across the cosmos. As astronomers continue to uncover and study these stellar fossils, they are piecing together a detailed narrative of how the Milky Way came to be, a story written in the light of stars that have outlived nearly everything else in the galaxy. Each discovery brings us closer to answering profound questions about the origins of the universe and our place within it. Now turning to one of the Milky Way's most fascinating and unexpected secrets, let's explore its hidden identity as a galactic cannibal. Imagine this: over billions of years, our galaxy has been steadily growing by devouring its smaller neighbors, incorporating their stars, gas, and even dark matter into its colossal structure. This process, known as galactic mergers, is not as chaotic as it might sound. Instead, it is a slow-motion cosmic dance where gravity takes the lead, pulling smaller galaxies into the grip of the Milky Way. One of the most compelling pieces of evidence for this comes from the Gaia-Enceladus event, an ancient galactic collision that left a profound impact on the Milky Way's structure. About 10 billion years ago, a dwarf galaxy crossed paths with the Milky Way, resulting in a dramatic merger. The stars from the Gaia-Enceladus galaxy were flung into elongated orbits, creating a distinct population of stars within the Milky Way's halo. What's even more astonishing is that these stars carry chemical fingerprints that differ from those formed within our galaxy, allowing scientists to distinguish between native Milky Way stars and the ones acquired through mergers. This evidence doesn't just tell us about the collision itself. It provides insight into the Milky Way's growth and evolution during its early stages. By studying these stellar remnants, astronomers can reconstruct the history of the Milky Way's formation, understanding how it grew from a collection of smaller protogalaxies into the magnificent barred spiral it is today. And this process isn't over. Even now, the Milky Way continues to consume smaller galaxies, including the Sagittarius dwarf galaxy, as it edges closer to our galactic core. These ongoing interactions remind us that our galaxy is far from static. It evolves and changes as it interacts with its cosmic surroundings. In uncovering these stories of galactic cannibalism, we gain a deeper appreciation for the dynamic, ever-changing nature of the Milky Way and the immense forces that have shaped it across time. Moving forward, let's uncover yet another hidden wonder of the Milky Way, the rogue planets. These mysterious celestial bodies defy the norms of planetary existence. Unlike the planets in our solar system, which orbit a parent star, rogue planets drift freely through the galaxy, unbound by the gravitational pull of any star. Imagine a world wandering alone in the dark void of space, with no sun to provide light or warmth. While this might sound like the premise of a science fiction story, it is a reality in our galaxy. Scientists estimate that there could be billions, yes, billions, of these rogue planets in the Milky Way alone. So how do these starless wanderers come to be? One theory suggests that rogue planets were initially formed around a parent star, just like Earth or Jupiter. However, violent events such as gravitational interactions with other planets or close encounters with passing stars may have ejected these worlds from their original systems, leaving them to roam the galaxy in solitude. Another possibility is that some rogue planets could form independently in interstellar space, bypassing the traditional process of star-planet formation entirely. These fascinating objects challenge our understanding of planetary formation and dynamics because they exist outside the star-dependent models that dominate current theories. What's more, studying rogue planets could help scientists uncover clues about the early stages of planetary and solar system development. Even though they are incredibly difficult to detect due to their lack of a host star, groundbreaking techniques like gravitational microlensing and advancements in infrared imaging are making it possible to identify these elusive wanderers. And when we do find them, there's always the tantalizing question: could some of these rogue planets harbor conditions suitable for life? After all, internal heat from a planet's core or other exotic mechanisms might sustain life even in the absence of a star. The study of rogue planets not only expands our understanding of planetary science, but also challenges our perceptions of what it means for a planet to be alive in the cosmos. And just as these worlds drift across the galaxy, our knowledge continues to grow, pushing the boundaries of what we thought we knew about the Milky Way's hidden treasures. Now turning to the next mystery, let's dive into the puzzling case of the missing lithium in the Milky Way. Lithium, one of the three elements produced in the earliest moments of the universe during the event known as the Big Bang, is surprisingly scarce in the stars of our galaxy. At first glance, this might not seem significant, but it poses a profound challenge to our understanding of stellar and cosmic evolution. Theoretically, the early universe produced an abundance of lithium along with hydrogen and helium. Yet, when scientists measure the lithium content in stars, they find far less than expected. So, where did all the lithium go? One hypothesis suggests that lithium in stars doesn't actually disappear but is instead destroyed in their cores. High temperatures in the interiors of stars can burn lithium, converting it into other elements through nuclear fusion. However, this explains only part of the mystery, since not all stars reach the extreme conditions needed to deplete lithium entirely. Another theory speculates that lithium may become locked away in certain layers of stars, hidden from view and inaccessible to our current measurement techniques. Some researchers even propose that processes in the Milky Way, such as interactions within interstellar gas clouds or the effects of supernova, could play a role in depleting lithium levels. There's also the intriguing idea that some of the missing lithium might exist in places we've yet to properly examine, like rogue planets, interstellar dust, or regions beyond our observational reach. Each of these hypotheses reflects just how much we still have to learn about the elements that shape the cosmos. Studying this lithium mystery not only helps us understand the behavior of stars and galaxies, but also offers deeper insights into the conditions of the early universe itself. It's a reminder that even a single element, seemingly small on the cosmic scale, can unlock profound secrets about the nature of existence. And with that in mind, let's continue our journey through the Milky Way's enigmas, moving forward to our next cosmic secret. As the next challenge unfolds, we arrive at one of the most baffling enigmas in astronomy, the stars that shouldn't even exist. Among these is the remarkable Methuselah star, a celestial object that has left scientists scratching their heads for decades. Why? Because measurements initially suggested that this star is older than the universe itself. Let that sink in for a moment, a star seemingly predating the Big Bang, the very event that gave rise to time, space, and everything we know. This paradox challenges the fundamental framework of cosmology. The Methuselah star, found within the Milky Way, has an incredibly low metal content, indicating that it formed in a primordial environment, possibly around 13.7 billion years ago. But our best estimates for the age of the universe place it at 13.8 billion years, creating a perplexing conflict. Could our calculations about the universe's age or the star's properties be wrong? Scientists believe that resolving this mystery might involve refining our understanding of both. Factors such as the exact distance to the Methuselah star and uncertainties in its chemical composition could slightly adjust its estimated age. But even with corrections, this star remains an extraordinarily ancient relic. Such anomalous stars force astronomers to rethink established theories about the timeline of star formation and the conditions of the early cosmos. Moreover, the Methuselah star is not alone. Several other stars also exhibit features that raise similar questions. These stars, defying conventional models of stellar evolution, act as cosmic time capsules, preserving clues about the earliest epochs of the universe. By studying them, we inch closer to unraveling the secrets of when and how the first stars emerged. So, what does the Methuselah star truly tell us? Perhaps it's a reminder that the cosmos is still full of surprises, challenging us to push the boundaries of our knowledge even further. With that intriguing idea in mind, let's move forward and uncover the next hidden mystery of the Milky Way. Moving forward, let's delve into one of the Milky Way's most elusive and unsettling phenomena, the hidden rogue black holes. Unlike the supermassive black hole Sagittarius A that anchors the center of our galaxy, these black holes are solitary wanderers untethered to any star system. Scattered throughout the Milky Way, rogue black holes are the remnants of massive stars that ended their lives in violent supernova explosions. What makes them particularly eerie is their invisibility. Since black holes emit no light, they are effectively cloaked in darkness, making them nearly impossible to detect directly. Yet, their immense gravitational pull gives them away, subtly influencing the orbits of nearby stars or bending light from more distant objects in a phenomenon known as gravitational lensing. These silent predators pose a potential danger to anything that crosses their path. A star, a planet, or even an entire solar system could be disrupted or worse, consumed, if they drift too close to one of these invisible giants. Scientists estimate that there could be tens of millions of rogue black holes quietly roaming our galaxy, each one a relic of a bygone era of stellar evolution. But how do we find something that is, by definition, invisible? Astronomers are employing ingenious methods, such as tracking the motion of stars that appear to orbit an unseen mass, or detecting subtle distortions in background starlight caused by a black hole's gravitational field. Additionally, advanced telescopes and observational techniques are constantly improving our ability to identify these stealthy cosmic entities. Every detection gives us new insights into the life cycles of stars and the hidden architecture of the Milky Way. The study of rogue black holes is not only a quest to understand their distribution and behavior, but also a journey into the darker, mysterious corners of our galaxy. These wandering enigmas remind us that the Milky Way is far from a static collection of stars and planets. It is a living, dynamic system filled with phenomena still waiting to be discovered. And with that thought in mind, let us journey on to reveal yet another incredible secret of our galactic home. With the next phase of the journey in sight, let us explore the concept of the Galactic Clock and the intricate dance of the Milky Way's rotation. Unlike the hands of a clock we see on Earth, this cosmic clock moves on an incomprehensibly vast scale. The Milky Way, a barred spiral galaxy, rotates as a whole with its stars, gas, and dust all revolving around the galactic center. Our own Sun, along with the entire solar system, is part of this motion, completing one full orbit around the Milky Way's core roughly every 230 million years, an event known as a cosmic year. This rotational movement is not uniform. Stars closer to the center complete their orbits faster, while those farther out move more slowly, a phenomenon dictated by the galaxy's gravitational dynamics and the mysterious presence of dark matter. Over the course of billions of years, this celestial choreography reshapes the positions of stars and constellations. For instance, the star patterns we see in today's night sky would have looked vastly different during the age of the dinosaurs and will look equally unrecognizable hundreds of millions of years into the future. The galactic clock also plays a role in cosmic events on Earth. Some researchers theorize that as our solar system orbits through denser regions of the galaxy, such as spiral arms or regions with higher concentrations of stars and interstellar material, the increased exposure to cosmic radiation or gravitational disruptions could influence the history of life on our planet, perhaps even contributing to mass extinction events. Beyond its scientific implications, the Galactic Clock is a humbling reminder of our place in the universe. It ties us to a cycle so immense in scale that it transcends our human concept of time. The next time you gaze at the stars, consider that both you and they are moving together in a cosmic waltz, a dance that began long before our species existed and will continue long after we are gone. As we ponder this grand mechanism, let us turn our attention to yet another marvel of our galaxy, one that offers a glimpse into its future and its twin among the stars. Now turning to the heart of our galaxy, we encounter a truly puzzling phenomenon: the mysterious radio signals emanating from the Milky Way's core. These enigmatic signals, detected by astronomers using powerful radio telescopes, originate in the vicinity of Sagittarius A, the supermassive black hole at the center of our galaxy. What makes them so intriguing is their irregularity and complexity, which deviate from many known astronomical sources. Some of these signals pulse in precise intervals, leading scientists to suspect they might be caused by pulsars rapidly spinning neutron stars emitting beams of radiation like cosmic lighthouses. However, not all of these signals fit neatly into the pulsar category. For instance, some exhibit patterns that turn on and off unpredictably, defying conventional explanations. Among the most baffling discoveries is a signal nicknamed ASCAP J173608 to 321,635, which scientists observed switching off completely for months at a time before reappearing unexpectedly, all while defying any recognizable pattern. This has led researchers to speculate about other potential sources, such as magnetars, which are neutron stars with incredibly strong magnetic fields, or even entirely unknown types of celestial phenomena. The study of these signals not only opens the door to understanding these exotic objects, but also pushes the boundaries of our knowledge about the extreme environments surrounding supermassive black holes. Deciphering the origins of these signals may one day unlock secrets about the dynamics of the galactic core, shedding light on processes that are otherwise hidden from view. As we uncover more clues about these mysterious radio waves, we are reminded of how much remains to be understood about our galaxy and the forces that govern it. Moving forward, let us explore an awe-inspiring connection between the Milky Way and its celestial counterpart, Andromeda, revealing what the future holds as these two galactic giants inch closer together. Now turning to the Milky Way celestial twin, the Andromeda Galaxy, we find an extraordinary mirror of our own galactic home. Located over 2 million light-years away from us, Andromeda is not only the closest spiral galaxy to the Milky Way, but also strikingly similar in structure and composition. Like our galaxy, Andromeda is a barred spiral galaxy with vast arms extending outward, teeming with billions of stars, planetary systems, and cosmic mysteries. However, what makes Andromeda truly fascinating is its trajectory. Over time, this galaxy has been moving toward the Milky Way at an astonishing speed of more than 70 miles per second. Scientists predict that in roughly 4.5 billion years, these two galactic titans will collide in an event that will fundamentally transform the cosmos as we know it. When their paths converge, the gravitational forces of this collision will trigger spectacular changes, causing stars to be flung into new trajectories, while others may merge or even ignite new star formation. This cosmic dance, though violent, is unlikely to result in direct collisions between stars due to the immense distances separating them. What will emerge from this collision is something entirely new, a single, merged galaxy often referred to as Milkomeda by astronomers. This new galaxy will be larger, reshaped, and perhaps even home to regions of extraordinary star formation as the remnants of these two galaxies settle into a new equilibrium. The impending union of the Milky Way and Andromeda is a stark reminder of the constant motion and evolution within the universe, offering a glimpse into the distant future of our cosmic neighborhood. As we marvel at this inevitable event, another story unfolds closer to home. let us now dive into the breathtaking stellar nurseries of the Milky Way, where the birth of stars paints a vivid picture of the galaxy's ongoing life cycle. Now turning to the vibrant heartbeats of our galaxy, the stellar nurseries, we find extraordinary regions where new stars are born. One of the most famous of these is the Orion Nebula, a dazzling cloud of gas and dust located approximately 1,300 light-years away. Stellar nurseries like this are the cradles of star formation, where immense gravitational forces pull together hydrogen gas and other elements to create dense cores. As these cores collapse under their own gravity, they heat up, eventually igniting nuclear fusion and giving birth to a new star. The journey from diffuse gas cloud to shining star is not only a marvel but also a reminder of the dynamic processes that continuously renew our galaxy. The Orion Nebula, for instance, is home to hundreds of young stars and protostars, surrounded by thick disks of material that may one day coalesce into planets. These regions are also shaped by powerful winds and radiation from the massive, newly formed stars, sculpting the surrounding clouds and influencing the next generation of star formation. Beyond the Orion Nebula, other star-forming regions, such as the Carina Nebula or the Eagle Nebula, showcase the incredible diversity of these cosmic birthplaces. Each nursery acts as a snapshot of the life cycle of our galaxy, demonstrating how it continually evolves and creates new stars to replace those that have burned out. These stellar nurseries are not just places of creation but also laboratories of cosmic chemistry, where elements created in previous generations of stars are recycled into new ones. As we explore these fascinating regions, we gain insight into both the Milky Way's present activity and its rich history of formation. From the intricate processes within a nebula to the magnificent stars they produce, stellar nurseries weave a vivid story of life and renewal in our galaxy. With this incredible cycle in mind, let us now delve into a different, more shadowy side of the Milky Way, where immense clouds of dust obscure light, creating cosmic mysteries that remain hidden to the naked eye. Now turning to the mysterious veils of our galaxy, let us explore the Milky Way's shadowy regions, where immense clouds of dust obscure visible light and hide countless cosmic wonders from the naked eye. These dense clouds, made up of tiny particles like carbon and silicates, can stretch across vast distances, blocking the light of stars and creating pockets of darkness even within the galaxy's brightest areas. To the human eye and traditional telescopes, such regions appear as voids, blank spaces where it seems that no stars exist, yet this shadow is far from empty. Buried within these clouds are hidden clusters of stars, young protostars, and even the remnants of ancient stellar explosions, all shrouded in an impenetrable cloak of cosmic dust. However, science has a remarkable tool for peeling back these layers of mystery. Infrared telescopes, which can detect heat radiation rather than visible light, have revolutionized how we see the Milky Way. Unlike visible light, infrared waves can penetrate through the dense dust clouds, revealing the stars and structures concealed within. With instruments like the James Webb Space Telescope, astronomers are now uncovering entire star-forming regions, detailed molecular structures, and even new types of stars that were invisible just a few decades ago. These discoveries not only provide a more complete picture of our galaxy, but also challenge our understanding of how stars and planets form under such hidden conditions. For instance, the famous pillars of creation in the Eagle Nebula, once shrouded in mystery, have been dramatically unveiled in stunning detail through infrared imaging, showing the intricate processes of star birth within their dense, dusty columns. These breakthroughs remind us that what may appear dark and hidden is often teeming with activity, waiting to be discovered with the right tools. This interplay of light and shadow, visibility and concealment, underscores the Milky Way's complexity and the endless opportunities for exploration it offers. As we marvel at these hidden realms, let us now turn our attention to an equally intriguing enigma: the mysterious rings of stars and gas that circle within our galaxy, presenting yet another puzzle of cosmic proportions. Moving forward, let us delve into the mysterious galactic rings that add another layer of intrigue to our Milky Way. These rings, vast structures of stars, gas, and dust, encircle the galaxy in patterns that challenge our understanding of how such formations come to be. Among these enigmatic features is the recently discovered Hercules ring, a colossal structure that has left scientists both amazed and puzzled. This ring is not just an ordinary cluster of stars, it is a coherent, circular formation located far from the Milky Way's central regions, raising questions about its origin and purpose. One leading theory suggests that such rings could be the remnants of past galactic mergers, where a smaller galaxy was absorbed by the Milky Way, leaving behind these circular trails of stars and gas as a sort of cosmic fingerprint. Another possibility is that these rings form as a result of the galaxy's gravitational interactions with its surrounding environment, including nearby satellite galaxies or streams of intergalactic gas. These interactions could create ripples in the Milky Way's disk, which over time settle into the stunning ring-like shapes we observe today. What makes the Hercules ring especially fascinating is its immense size and symmetry, which suggests that it could be much older than previously thought, possibly dating back to some of the earliest events in the Milky Way's formation. Furthermore, studying these rings provides astronomers with vital clues about the history of our galaxy's growth and the dynamic processes that continue to shape it. By analyzing the composition and motion of the stars within the Hercules ring, researchers hope to uncover details about the Milky Way's interactions with its cosmic neighbors and the forces that govern its evolution. These galactic rings remind us that even within the seemingly uniform structure of our galaxy, there exist complex and beautiful anomalies that defy simple explanation. With this in mind, let us now turn to another fascinating feature of the Milky Way, its vast and invisible magnetic field, a phenomenon as elusive as it is essential to understanding the galaxy's deeper workings. Now turning to one of the most elusive and essential phenomena of our galaxy, let's explore the Milky Way's vast and invisible magnetic field. Unlike the magnetic fields of planets like Earth, which are relatively well understood, the galaxy's magnetic field stretches across tens of thousands of light-years, weaving through its stars, gas, and dust. This colossal force, though invisible, plays a critical role in shaping the Milky Way's structure and behavior. It interacts with high-energy particles known as cosmic rays, influencing their motion as they traverse the galaxy. These interactions affect everything from the formation of new stars to the movement of interstellar gas. One of the most fascinating aspects of the Milky Way's magnetic field is how its strength and direction vary throughout different regions of the galaxy. Near the galactic plane, where stars and gas are most concentrated, the magnetic field acts almost like a skeleton, providing a framework that organizes the chaotic movement of matter. In the outer regions, this field becomes weaker but still exerts influence over the sprawling clouds of gas that extend far beyond the visible edges of the galaxy. Scientists face enormous challenges in studying this phenomenon, primarily because it cannot be observed directly. Instead, they rely on indirect methods such as analyzing the light from distant stars. As this light passes through the galaxy, it becomes polarized, essentially twisted by the magnetic field, offering clues about the field's structure and orientation. Another tool astronomers use involves mapping the distribution of charged particles or plasma, which tend to align with the magnetic field lines. Yet, despite these advances, much about the Milky Way's magnetic field remains a mystery. Where does it originate? How has it evolved over billions of years? And how does it compare to the magnetic fields of other galaxies? These unanswered questions are a testament to the complexity of our galaxy and the limits of our current technology. However, studying the Milky Way's magnetic field is not just an academic exercise. It has real implications for understanding the universe. Magnetic fields are thought to play a vital role in regulating star formation, guiding interstellar winds, and even shaping the large-scale structure of our cosmic environment. By unraveling the secrets of our galaxy's magnetic field, scientists hope to gain deeper insights into how galaxies like the Milky Way form and evolve. With this enigmatic force in mind, let us now move to another captivating paradox of the Milky Way, the unexpected scarcity of supernova explosions, a mystery that challenges our understanding of stellar death and rebirth. Moving forward, we arrive at one of the most perplexing mysteries of the Milky Way, the curious lack of observed supernova explosions. Supernova, the stunningly powerful deaths of massive stars, are expected to occur relatively frequently in a galaxy of our size, roughly one every 50 years. Yet, when we turn our telescopes toward the Milky Way, the number of supernova we actually detect falls far short of what models predict. This puzzling scarcity raises a simple yet profound question: where are they hiding? One explanation could lie in the vast layers of interstellar dust that cloak much of the galaxy. These immense clouds of particles obscure our view, blocking visible light from reaching Earth. As a result, many supernova may simply occur unnoticed behind this cosmic curtain. To overcome this challenge, scientists use tools such as X-ray and infrared telescopes, which can see through the dust and detect the energy signatures of these hidden explosions. But even with these advanced technologies, the numbers still don't add up. Another intriguing possibility is that some supernova might not produce the spectacular fireworks display we traditionally associate with them. In rare cases, massive stars could collapse directly into black holes without emitting the light and energy that typically mark a supernova event. This would make them nearly impossible to observe with conventional methods, effectively rendering them invisible to us. Then there's the challenge of time. The remnants of supernova, expanding clouds of gas and dust, can linger for tens of thousands of years, but the initial explosion itself is fleeting, lasting only days or weeks. If we aren't looking in the right place at the right time, we could easily miss these rare phenomena altogether. This fleeting nature is compounded by the sheer size of the Milky Way. With hundreds of billions of stars spread across a disk over 100,000 light-years wide, tracking every corner of the galaxy for a brief event like a supernova is a monumental task. Yet despite these obstacles, progress is being made. By studying neutrinos, tiny, nearly massless particles released during supernova explosions, scientists are beginning to uncover evidence of these hidden stellar deaths. Neutrino detectors buried deep underground on Earth can capture these elusive particles and provide direct evidence of supernova that might otherwise go unnoticed. These groundbreaking efforts are slowly but surely revealing the true scale of supernova activity within our galaxy. Beyond the mystery of their apparent scarcity, understanding supernova is crucial because these explosions are the universe's ultimate recycling machines. They scatter heavy elements like iron, gold, and uranium, essential ingredients for planet's life, and even the technology we use today, into the surrounding space. Without supernova, the Milky Way wouldn't be the dynamic, evolving system it is, and life as we know it may never have emerged. As we continue to explore these hidden cataclysms, we're reminded of just how much more there is to uncover about the Milky Way secrets. With this mystery in mind, let us now turn our attention to an entirely different cosmic enigma: the astonishing velocities of hypervelocity stars, rogue travelers flung across the galaxy at unimaginable speeds. Now turning to the next cosmic wonder, we uncover the mysteries of hypervelocity stars, celestial speedsters traveling through space at staggering velocities. These incredible stars are not just sprinting across the Milky Way. Some are moving so fast that they are on trajectories to escape the galaxy entirely. Their astonishing speed can exceed 1 million miles per hour, a velocity so immense that it defies ordinary comprehension. But what could possibly fling these stars into such extraordinary motion? The answer lies in the dramatic gravitational interactions near Sagittarius A*, the supermassive black hole at the center of our galaxy. When a binary star system, which is two stars bound together by their mutual gravity, ventures too close to this black hole, one star can be captured by Sagittarius A's immense gravitational pull. The other star, however, is violently ejected outward, slingshot like a cosmic cannonball. This explosive interaction catapults the star across the galaxy at previously unimaginable speeds, turning it into a hypervelocity star. What makes these speeding stars even more fascinating is their potential to escape the Milky Way altogether, entering the vast reaches of intergalactic space. Imagine a star born in the dense heart of our galaxy, now hurtling toward the emptiness between galaxies, carrying the story of its origin into uncharted cosmic territory. These rogue stars are not just anomalies, they are valuable clues in understanding the dynamics of black holes, the structure of the galaxy, and even the gravitational forces that shape the cosmos. By studying their trajectories, scientists can retrace their journeys back to the galactic core, providing a deeper understanding of Sagittarius A* and the events unfolding in its vicinity. Additionally, hypervelocity stars serve as natural probes of the Galactic Halo, the outer region of the Milky Way filled with dark matter and scattered stars. As these stars traverse this region, their movements can reveal information about the distribution of matter, both visible and invisible. This makes hypervelocity stars not only cosmic marvels but also critical tools for unraveling the hidden framework of our galaxy. As we trace these speeding travelers and ponder their extraordinary journeys, we are reminded once again of the complexity and wonder that defines the Milky Way. And from the fast-paced spectacle of hypervelocity stars, we now shift our focus to another intricate and mysterious feature: the ancient siblings of our home galaxy, scattered across the universe like echoes of a shared cosmic past. Now turning to the final secret of our journey, we unveil the story of the Milky Way's lost brothers galaxies that once shared a cosmic cradle with our own, but are now scattered across the vast expanse of the universe. Scientists believe that the Milky Way was not born in isolation but as part of a cluster of sibling galaxies, formed from the same primordial materials in the early universe. These galactic siblings would have shared similar structures and compositions, growing together in a tightly knit celestial neighborhood. However, over billions of years, the intense gravitational interactions within this cluster acted like cosmic billiard shots, flinging these galaxies apart and sending them on their own unique journeys through space. Today, the remnants of this ancient galactic family are incredibly difficult to trace as they have drifted far across the universe. Yet, astronomers have uncovered tantalizing evidence of these lost brothers. By studying galactic movements, chemical compositions, and star populations, researchers have identified similar galaxies that may share a common origin with the Milky Way. For example, large spiral galaxies like Andromeda bear striking similarities, hinting at a long-lost kinship. Even smaller galaxies, such as the Magellanic Clouds, may hold clues about our galaxy's early companions. These findings paint a picture of the Milky Way's formative years, a time when our galaxy was not alone but part of a larger cosmic community. Beyond the scientific intrigue, the tale of the Milky Way's lost brothers reminds us of the ever-changing and dynamic nature of the universe. It is a story of separation, survival, and transformation, echoing the journey of our own galaxy as it evolved into the stellar metropolis we see today. As we piece together this evidence and imagine the far-flung locations of these galactic siblings, we are left with a sense of wonder at the shared history that connects our Milky Way to the broader cosmic tapestry. And with this final secret revealed, we close our exploration of the incredible mysteries that define our home in the universe, leaving us awestruck by how much there is yet to discover. With the next phase of the journey in sight, let us delve deeper into the role of Sagittarius A*, the supermassive black hole anchoring the Milky Way, and how it has shaped our galaxy over billions of years. Sagittarius A* is not merely a colossal gravitational force at the heart of our galaxy. It is a dynamic entity that has influenced the Milky Way's evolution in ways both seen and unseen. Over cosmic time, this supermassive black hole has acted as a galactic conductor, orchestrating the movement of stars, gas, and other materials. Its immense gravitational pull governs the rotation of stars within the galaxy, ensuring that they trace their orbits around the galactic center in a coordinated celestial dance. But Sagittarius A* does not just dictate motion. It also plays a pivotal role in energy distribution across the Milky Way. Periodically, this black hole undergoes activity bursts, likely ignited by the swallowing of nearby stars or gas clouds. These eruptions send ripples of energy across the galaxy, affecting star formation in surrounding regions. Some scientists hypothesize that such bursts may even have triggered waves of star birth in the past, creating clusters of stars that form some of the most beautiful structures we observe today. On the flip side, Sagittarius A* can also act as a suppressor of star formation. During particularly active phases, the energy it releases can heat vast gas clouds, preventing them from cooling and collapsing into new stars. This dual role of creator and destroyer highlights how deeply interconnected this black hole is with the very fabric of the Milky Way. Its influence extends far beyond the immediate vicinity of the galactic core, shaping the evolution of the galaxy as a whole. As we look toward the future, scientists are working to uncover even more about Sagittarius A* and its complex history. With advancements in observational technologies, we may one day witness its hidden actions in stunning detail, revealing how this enigmatic powerhouse continues to shape the story of our galaxy. Moving forward, let us unravel the significance of the Milky Way's bar structure and its profound role in galactic evolution. The Milky Way is not merely a spiral galaxy, it is a barred spiral galaxy, a distinction that reshapes our understanding of its dynamics. At the galaxy's core lies a central bar of stars and gas that stretches across the heart of the spiral arms. This structure acts as both a bridge and a channel, funneling massive amounts of gas from the outer regions of the galaxy toward the central regions. This redistribution of gas is critical because it serves as the raw material for star formation. As the gas is funneled inward, it triggers bursts of new star creation near the galactic core, giving rise to some of the most densely packed star clusters in the galaxy. But the bar does more than just create stars. It influences the orbits of stars and gas throughout the Milky Way. Its gravitational pull helps to organize the motion of stars in the disk, shaping the spiral arms and regulating their patterns. Without this bar, the Milky Way's iconic spiral arms might not exist in their current form. The bar also plays a role in regulating the overall evolution of the galaxy. By redistributing gas, it can either fuel future star formation or exhaust the available resources, determining the Milky Way's pace of growth and change over time. Recent studies suggest that the size and strength of the bar have changed throughout the galaxy's history, pointing to a dynamic feature that evolves alongside the Milky Way itself. This evolution offers a glimpse into the galaxy's past and provides clues about its future. As we continue to study this intriguing structure, astronomers are uncovering the hidden mechanics that make the bar not just a feature, but a driving force in the ongoing story of the Milky Way. Now turning to the fascinating phenomenon of galactic cannibalism, let us delve into the ongoing disruption of the Sagittarius dwarf galaxy and what it reveals about the Milky Way's insatiable appetite for growth. The Sagittarius dwarf galaxy, a smaller satellite of the Milky Way, is currently being torn apart by our galaxy's immense gravitational pull. Over the course of billions of years, this dwarf galaxy has made multiple passes around the Milky Way, each time losing more of its stars and gas to our galaxy's powerful forces. Recent discoveries, thanks to precise mapping by the European Space Agency's Gaia mission, have unveiled long, faint streams of stars stretching across the sky. These are the remnants of the Sagittarius dwarf galaxy. These stellar streams not only confirm the ongoing act of galactic cannibalism, but also offer a treasure trove of information about the Milky Way's growth. By analyzing the positions and motions of these stars, scientists can reconstruct the history of this cosmic interaction, revealing how the Milky Way's structure and size have been shaped by devouring smaller galaxies like Sagittarius. This process is not a violent clash, but rather a gradual pulling apart, where the smaller galaxy is shredded into streams that eventually blend into the Milky Way. Such interactions play a crucial role in the evolution of galaxies like ours, as the infalling material provides fresh fuel for star formation and even contributes to the thickening of the galactic disk. The disruption of the Sagittarius dwarf galaxy is a vivid reminder that the Milky Way is not a static entity. It is a living, evolving system that grows by consuming others. In the far future, this process may further reshape our galaxy, adding new stars and altering its structure in ways we are only beginning to understand. With these ongoing discoveries, scientists are piecing together a dynamic narrative of how the Milky Way continues to thrive and transform through its interactions with smaller galaxies. Moving forward, let us focus on our solar system's unique journey within the Milky Way's vast expanse and how this cosmic motion influences life on Earth. Our solar system orbits the galactic center at an average speed of about 500,000 miles per hour, completing one full revolution roughly every 230 million years. Known as the galactic year, this immense cycle is not just a fascinating journey but one with profound implications for our planet. As the solar system travels through different regions of the Milky Way, it encounters varying densities of gas, dust, and other cosmic material. Some scientists theorize that these movements through denser areas of the galaxy, such as spiral arms or regions of heightened star formation, may have coincided with mass extinction events on Earth. For instance, increased exposure to supernova explosions or cosmic rays in these regions could potentially affect Earth's atmosphere, altering climate or even increasing mutation rates in organisms. Additionally, gravitational interactions with nearby stars during our orbit could dislodge comets from the distant Oort cloud, sending them hurtling toward the inner solar system and increasing the likelihood of impact events. While these theories remain under investigation, they underscore the intricate connection between our place in the galaxy and the history of life on Earth. The solar system's movement also influences the broader understanding of how stars and their planets interact with their galactic environment over cosmic timescales. Such revelations are a reminder that Earth's story is deeply intertwined with the Milky Way's dynamic dance, a relationship that continues to shape our planet in ways we are only beginning to comprehend. As we unravel these mysteries, the grand narrative of our solar system's place in the galaxy becomes ever more captivating. Now, let us delve deeper into the enigmatic world of the Milky Way's hidden stars, shrouded in darkness yet illuminating secrets of our galaxy's unseen realms. Now turning to the remarkable discovery of hidden stars, we venture into the concealed regions of the Milky Way that have long evaded our view. For decades, dense clouds of gas and dust have acted as cosmic curtains, obscuring vast areas of our galaxy from optical telescopes. However, with the advent of advanced technology such as the James Webb Space Telescope, scientists are now peeling back these layers to reveal countless stars previously hidden from sight. Using its powerful infrared imaging capabilities, this telescope can penetrate the thick veils of interstellar dust, unveiling stellar nurseries where new stars are forming and even uncovering ancient stars whose light has been shrouded for billions of years. This breakthrough technology is not only expanding our catalog of stars, but also reshaping our understanding of the Milky Way's structure and evolution. Among these discoveries are stars that challenge existing models of stellar formation, offering glimpses into environments so extreme that they push the boundaries of what we thought possible. Hidden within these clouds, scientists have also identified clusters of stars that could hold clues to the galaxy's earliest days, providing a window into its infancy. These findings illuminate just how much of the Milky Way remains unexplored and demonstrate the profound potential of modern telescopes to unlock its secrets. Each hidden star uncovered is a testament to the galaxy's complexity, reminding us that even in the most cloaked regions of space, there is light waiting to be found. As we unveil these stars one by one, our perspective of the Milky Way grows richer, adding more depth to the intricate tapestry of our cosmic home. Moving forward, let us explore another fascinating cosmic enigma: the surprising scarcity of visible supernova within the Milky Way, and what this mystery reveals about the death of stars hidden in plain sight. Moving forward, let us delve into the intriguing mystery of hidden supernova within the Milky Way, an enigma that challenges what we know about the life and death of massive stars. Supernova are the spectacular explosions marking the final moments of a star's life, events so powerful they can outshine an entire galaxy for a brief time. Yet within the Milky Way, far fewer supernovae are observed than expected based on the number of massive stars that should end their lives in such explosions. This scarcity has puzzled astronomers for years, leading to the theory that many supernovae might be hidden from view, shrouded by the dense clouds of gas and dust that permeate our galaxy. Recent advancements in neutrino detection are offering a groundbreaking solution to this cosmic puzzle. Neutrinos, tiny, nearly massless particles, are released in enormous quantities during a supernova explosion. Unlike light, neutrinos can pass through thick layers of interstellar matter without being obstructed, making them invaluable messengers from these hidden events. Sophisticated neutrino observatories like the Supermassive and Detector and others are now enabling scientists to trace these elusive particles back to their source, detecting the faint signals of concealed supernova buried deep within the Milky Way's obscured regions. This ability to unveil hidden supernova not only allows astronomers to better track the true rate of star deaths in our galaxy, but also provides new insights into the physics of these extraordinary explosions, such as how they disperse elements critical for life into the cosmos. Each neutrino detection brings us closer to bridging the gap in our understanding, revealing a more complete picture of the Milky Way's life cycle. As we uncover these cosmic events one by one, we are reminded of the profound interconnectedness of life and death in the galaxy's endless cycle of creation. Now let us turn our gaze to the fastest stars in the Milky Way, which travel through space at astonishing speeds, defying what we thought was possible. Now, as our journey through the secrets of the Milky Way comes to a close, let us take a moment to reflect on the marvels we have uncovered. From the supermassive black hole anchoring our galaxy to the mysterious gamma-ray bubbles, and from the hidden realms of dark matter to the astonishing speeds of hypervelocity stars, each revelation deepens our understanding of the Milky Way as a vibrant, dynamic entity. We have explored star nurseries, uncovered hidden supernova through neutrino detection, and even ventured into the realm of rogue planets adrift in the cosmic void. These discoveries remind us of the Milky Way's intricate balance of creation and destruction, a constant dance of forces shaping the past, present, and future of our galactic home. Even with all these incredible insights, the mysteries of the Milky Way are far from fully unraveled. Each breakthrough reveals new questions, new layers of intrigue, and new horizons to explore. The universe is vast, its secrets seemingly infinite, and our journey of discovery has only just begun. Which of these secrets amazed you the most? Share your thoughts in the comments below. And if you are as captivated by cosmic mysteries as we are, Be sure to like this video, subscribe to our channel, and turn on notifications so you never miss an opportunity to explore the wonders of the universe. Thank you for embarking on this journey with us, and until next time, keep looking up and marveling at the cosmos above.